Hi. So you're applying for the role of the data analyst position?
Hi, yes, I'm Jackson Lanier, and I'm applying for the role of data analyst.
Great. Let me ask you a few questions related to that role. What does the CRISP DM methodology for data mining entail? And what does the data analyst do in each step?
Okay, CRISP-DM, or the Cross-Industry Standard Process for Data Mining, is a six-step process used in data mining. It's not the only approach to data mining, but it's widely used and has solid structure with well-defined steps. The first step is business understanding. As the name implies, the purpose of the step is to gain a clear understanding of business goals and priorities. This allows data analysts to tailor their work to a business's needs. During this step, the data analyst may discuss business objectives with stakeholders in order to define what success means for the project. Once the objectives are clear, a project plan can be formulated. The second step is data understanding, which involves collecting data and performing an initial overview of the data. The analyst should check the data for any issues, like missing values or inconsistencies. And it's important to start documenting a description of the data during this step. As the analyst explores the data, documenting findings such as format, descriptive statistics, relationships, and quality will help with understanding the data. Step three is data preparation. A large portion of the project is generally dedicated to data preparation. Data prep can involve several steps. Analysts will select and clean the data to be used in the project. They may construct or derive new data if necessary. Reformatting data might also be needed. Much of this step depends on the data available and the data's condition. Fourth step is modeling. In this step, the analyst will select and try out models. This means visually representing the data through the use of logic and algorithms. The analyst will likely pick modeling techniques like regression or a decision tree and apply the models to the data. Testing prototype models will be necessary to gauge which model is a best fit for the project. Step five is evaluation. The evaluation process involves taking a step back to review project progress and make sure business needs and objectives are going to be met with the model being considered. Analysts will need to review the entire data mining process and determine if anything has been overlooked. They'll need to decide whether a specific model can be selected for deployment or if adjustments to data or modeling are needed. Step six is deployment. Deployment can involve a variety of tasks. Implementing a model into a production environment is often the first task. The decision to implement may be made by a combination of data analysts and other stakeholders. Once a model is implemented, analysts are often responsible for monitoring a model's performance, maybe performing model maintenance and producing reports on the results of the model's use, as well as success of the project as a whole. Documentation throughout this step, as well as the entire process, is an important part of successful data mining and helps with improving future projects.
Okay, great in depth answer. Let's keep going. Explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve?
There are several steps that need to be taken before performing a time series analysis. The first step is to collect data. Without a sufficient amount of data, a forecast is not going to be effective. The data needs to span across time. The amount of data needed and the length of time covered by the data will depend on the objective of the forecast. Once you've gathered data, the data will need to be cleaned and explored. Cleaning data involves identifying outliers, addressing missing data points, detecting anomalies, and transforming data when necessary. An analyst will need to choose whether to remove outliers or input missing data points as part of the cleaning process. Exploring the data helps analysts get to know their data. Using descriptive statistics as well as other statistical tools like box plots and histograms can identify trends and patterns in data. Next, you'll want to check the data for stationarity and seasonality. Data is stationary if its mean and variance stay the same over time. Stationary data won't display a trend heading in one direction. Data displays seasonality if it fluctuates regularly and at periodic intervals, such as a business's sales spiking every year during the holidays. Non-stationary data may need to be transformed into stationary data depending on the type of time series forecast that will be used. The accuracy of forecasting models can be improved by using stationary data as opposed to non-stationary data. Seasonality may also need to be removed during the transformation process. Achieving stationarity can be done by using techniques such as detrending and decomposition. Once the data is prepared, you'll use a model to perform the time series forecast. Depending on the data and the goals of the forecast, the model or technique used may be something simple like a moving average or something more complex like an ARIMA.
All right, here's a good one. Discuss the main principles of data ethics, as well as what companies or organizations could do to uphold these principles.
Data ethics are based in morality and help determine what is right and wrong with working with data. Though the makeup of data ethics is forever ongoing, there are four main principles that should always be practiced. Privacy in data ethics means that individuals should be in control of their personal data. Companies and organizations must follow laws regarding individuals' privacy and should get consent before using private info, such as individuals' names. Transparency in data means being open and clear about data that is collected, used, and shared. An organization should be transparent with how they collect, process, and share data. They should be transparent with the employees of the organization as well as the public. It's important not to trade off privacy for transparency, though. There can be a balance of both principles. Another principle is accountability, which insists that organizations are responsible for the data they collect and how it is used and shared. For example, if an organization collects private data that is unintentionally leaked or stolen, they should take responsibility. And staying in line with transparency, they should be open about what's happened to the data. The fourth principle is equality. It's an important principle of data ethics that tries to ensure individuals and groups are not discriminated against as data is collected and processed. Human bias is unfortunately unavoidable in data collecting and processing, but organizations can take steps to avoid bias. This, in turn, can prevent discrimination. Practicing equality is important because it leads to more honest and fair data driven decisions that build trust between organizations and the public.
Great. All right. For this question, imagine you're an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with your manager?
If I had concerns about bias in a measurement, I'd first try and approach my manager in a one on one setting, perhaps over a call or in a private meeting. When explaining the concern, I'd use specific examples that clearly show potential measurement bias. If possible, I'd provide evidence, such as comparing the bias measurement to an unbiased measurement of the model. It could be helpful to explain the negative consequences of the bias, like unfair treatment of customers or inaccurate predictions. The manager might also appreciate if I offered potential solutions, like adjusting the model to avoid bias. One suggestion for avoiding measurement bias in the future is to revisit the data collection process. Is the data being collected accurate, or are there any issues with the collection process? A regular review or audit of the predictive model to ensure it is functioning properly could also prevent measurement bias. If there are multiple employees involved in measuring the predictive model, comparing the employees' measurements to look for major differences or outliers could also help identify and prevent bias.
Okay, last question. Explain the difference between regression and classification models in predictive analysis. When would you use one of these models over the other?
Regression models measure the relationship between variables in order to show how one or more variables can affect another variable in order to make predictions. The variables used in a regression model need to be numeric. A simple linear regression can measure the relationship between one dependent variable and one independent variable, while a multiple linear regression can measure the relationship of more than one independent variable and one dependent variable. And these aren't the only types of regression models, there are plenty of different kinds. Regression can be used to predict the price of a good based on input variables, like predicting the price of a house based on square footage and location. Regression models could also predict the number of expected customers a business will have based on previous customer counts and an independent variable like sales or money spent on marketing. Classification models are all about categories. Unlike regression, classification models are used to predict a discrete category a variable will fall into based on input factors. For example, classification can be used to predict whether or not an email is spam based on factors about the email, such as the subject or the contents of the email. In this example, binary classification groups predictions into yes or no categories. But classification can also be used to group predictions based on multiple possible outcomes, such as predicting what film genre someone using a streaming service would like based on factors like their previous film choices and their age. I'd use a regression model in cases where I want to predict a continuous numeric value, like the price of a good or the number of expected customers. Whereas I'd use a classification model to predict discrete categories, like predicting whether or not an event will occur or predicting whether a customer's reaction will be positive, negative, or neutral.
All right, Jackson, you'll be hearing from us.
I'm looking forward to it. Thank you for your time.